Hey everybody, this is Design Magic. I'm Kevin. Today we're going to discuss spray welding and how I developed the process for it. I'm not going to get in the technical end of it. I'm going to be trying to encourage people to step out of their comfort zone and challenge themselves to design and come up with new ideas. I thought I would mention why did I call it Design Magic. In fact, right now I'm not even quite sure I like the name. However, I wanted to include something from my past. And the shop that I had, which was all types of machine and metal fabrication, welding, also repair work of engines or anything, and painting as well, trick paint jobs on cars and stuff. I called it Metal Magic because my big thing was I enjoyed working with metal. Nowadays my design abilities have gone beyond that. Because I design even floor plans for buildings and designed processes, things like that. Just anything. Anything can be improved. Anything can be repaired. Well, even if it can't be, it can be created in some new fashion. And so you gotta, step out of your comfort zone to do that. I want to point out something here. A lot of new ideas don't come from the established, the established knowledge of the product. A lot of the new ideas for engines, suspensions, the way you build a house, the way you cook your food, come from people that didn't come from any training or any special background. And I like to think of myself as one of those people. I don't have any specific training. I mean, I've had some, but I think outside of the box quite a bit. So now we're talking about spray welding. Unfortunately, I don't know how to use the computer that well, and I kind of like my method because it's simple. But here is a picture of me spray welding the housing of a pump. Now that's cast iron. That's where spray welding is rather interesting for repairs. This type of metal build-up was really designed for where you have a surface that's been worn down, like the shaft of a gearbox or something like that, where a bearing spun in the shaft and it tore the shaft up. So rather than machine a whole new shaft, they mount the shaft up into a lathe, and while it's spinning slowly, they heat it up and then use metal powder and spray it onto the shaft and build it back up, then return the shaft. They can do that either with actual powder, or in cases where they have a huge shaft, which just is where it's used a lot, they have a coil of wire, and as the wire comes into the gun that's going to spray it out, it is actually ground up right there and turned into powder, and then goes out through the oxyacetylene torch, which doesn't always have to be acetylene. However, that's what I was used to using. Now, when I developed the process of welding with it, where if you have a crack or you literally have two parts that are separated, I was mainly focusing on cast iron. The reason this came about was I was lucky enough that Allstate Welding, that made this product and the gun that I was using in that picture, happened to be in the town that I lived in. And I would go out there to buy my powder, and then I would get hooked up with their R&D guy and see what they were up to. And he always was a barrel of energy, and so I would learn a lot of stuff from him. And he mentioned how well it bonds to cast iron, which this, I believe, is more of a welding process. It's kind of like in between, but I think the temperature range is up there high enough that it'd be considered welding, not brazing, like brass or silver. But what made it work good for cast iron is to help it flow and all, they had a high nickel content in some of the powders, some others not necessarily. So I ended up trying it as a method for welding. Now, at first you'd say, well, it's not really designed for that. However, what I found, and part of the reason it wasn't designed for that, is because it didn't have the tensile strength of the original metal. The cast iron was actually stronger. But there were welding methods that were stronger, with stick welding with a high nickel rod. The thing is when you got done the weld, there was zero porosity on the spray weld. And had you done your original passes correctly, which is you blow the powder on before the metal is actually up to temperature, because you want to stop oxidation from happening. And then you bring your metal up to the melting point where the powder blends in and adheres to the cast iron. Then after that, you're doing a building process where you're just building on top of your powder, not on top of the cast iron. And so there you had zero porosity, and because of the makeup of the powder, you didn't have to deal with oxidation. So you didn't have the scaling problem. So I was using it to weld, and they said, well, it's not for welding. I said, well, the thing is I can get a better adhesion to the original metal, and I get zero porosity. I have so much more control over it than when I'm stick welding. When I'm stick welding, I have to preheat the materials that I'm going to weld using another method other than the stick. Then I have the stick weld, which puts a huge amount of heat into the material when it's welding. You have a lot more chance of porosity. In fact, you have porosity. That's just how it works. I mean, you can do it without porosity, but it takes a lot of time, a lot of effort, and it's actually a lot slower because you have to stop, you have to chip slag, you have to let it cool, and then you weld a little more, then you stop, then you let it cool, then you chip the slag, and you go over this and over it. Where this process, watching the temperature of the material by the color, the glow, you can just keep moving and and get it done much faster and much stronger. Even though the tensile strength is, we'll say, like 10,000 less, because you have better adhesion and no porosity, you got a better weld anyway. So here they realized that this is true, and so they started promoting it as a welding process. But then on top of that, I went and I did something, and let me teach you something about designing and doing things. It's best not to know what can and can't be done, okay? Because if you don't know it can't be done, you're going to try it, and you might find a way to make it work. Where somebody who's told it can't be done just doesn't try. So if you are told it can't be done, then you still have to have the right mental makeup to say, well, I'm going to try anyway, you know. And you will. You'll find out that a lot of times people don't know what they're talking about. They haven't tried it. They haven't thought about how you looked at it. You never know. I have stories about even running a computer where they said, don't punch this button. And after I punched the button, it wasn't a problem. Of course, I have stories going the other way, but there's only one way to find out. And so I did. So here's something we came into. Now this is a Detroit engine. This is a Detroit head off of course, a 6-cylinder Detroit engine. I say, of course, this is a V6. The center chamber detonation caused all that ugliness. And there's a crack in between the two ports on the left and the right hand side. So I took my process and I spray welded all that detonation up. I haven't fixed the cracks yet, but I'll grind a deep V in there, bevel it out. I'll spray down in there and then build it up to where it covers to above the surface of the head. It worked for me a lot of the time. Now, welding up heads, it was not consistent though. The problem with the head is because of all the differences in thicknesses and openings because of the water jackets and stuff like that in the head, I never knew for sure if I was going to re-crack the head in cooling or not. That was the problem. Now, I did find out that if I could slow the cooling process, a lot of times it would work. But I never invested in an oven because I just didn't see the volume of work for me anyway. There's also another reason, and I'll probably get to that in my why me sometime down the road. So here's what it looked like when it was done. There is a slight difference in color, but in this picture you can't really see it. And that head went to live on for another extended period of time. So that's one of my designs. I'm very proud of that, really, because the people from that company actually came out there. Allstate Welding Products came out to my shop. We were just on the opposite ends of town to watch me work on this, and the R&D guy came out as well. And I can remember the one guy said, "He does this stuff like a professional." And the R&D guy looked at him and said, "That's because he is a professional." You might want to remember that too. Sometimes you feel like you don't deserve to have the success that you do, or because you're not trained or something like that, that your chances of succeeding are less. Well, no, that's not the case. So, you know, I was a professional. Nobody else could do it. Nobody else knew how. Not yet. I showed them how. It wasn't any big secret. In fact, I already have told it to you, but I'll specify. You got to get that first coat of powder on before you reach your melting point, because your cast iron will oxidate and will then flake off carbon, I believe it is, which will then contaminate your weld. So by spraying a coat of that on, that blocks the oxygen from getting to the cast iron. And that's what makes it succeed. Now, and what makes it fail is cooling. If it can't cool evenly, if you have a unusual shape, then you might have problems. But I know that I saved a lot of people a lot of money, because I was able to repair what they had instead of them having to go out and buy new. So, we'll see you on the next design magic. Thanks a lot.